All right. Class.
Yes.
That's actually not bad. Not bad. But I didn't hear Fred on that one.
I really say yes.
You heard him? You heard him? Okay, good. All right. So what page number are we on for today's notes?
9.
This one's going to be 9. All right. So this one here should be page 9. The homework is going to go on page 8. Wow. It's going to be one of those mornings. So page 9, especially for those people that still don't have their notebook, please write the number on it so when we connect this in, let me see, I'm collecting it in 6 weeks. Yeah. Right before spring break. So I'm actually collecting it the Friday before spring break, but for this class it would be the Thursday before spring break, like the week before. I'm not going to do it during spring break because I don't want to look at or even think about any of you at all during spring break. Not to be mean, but it's the vacation's for me, not for you, just so you guys realize that. Yes, it's my break from you. No, seriously, I will get over it with a whole lot of day drinking. Okay? Anyway, all right, so for this one right here, says coloring. A coloring of a graph is assigning a color to each vertex. Now, what else do we call vertex? The vertices, right? And in our analogy, they've been houses, right? Because we were doing, what were we doing? With the Hamiltonian, pizza delivery, and with the Euler, we did the trick-or-treating, right? So we are taking all the roads with the Euler, yes? Okay, you guys kind of remember that, hopefully? All right, so it says, so that no two vertices joined by any edge are assigned the same color. Labeling with colors is useful for solving problems that require minimization, efficiency, or conflict resolution. That means that we're going to try and use the least amount of colors, or let's say, for instance, in a classroom. Okay, in a classroom, I cannot put Fred by certain other people. So I have to make sure Fred is away from other people. So when I am doing a seating chart, certain people cannot sit by Fred. So I have to try and arrange it like that. Fred and Preston, no, that's a no-go, okay? Fred, Preston, and Smokey, definitely no-go, okay? Brock and anyone, okay? Brock should be by himself, okay? We love you, Brock. We miss you. All right. So label the colors useful for problem solving that require minimization, efficiency, or conflict resolution. So chromatic number. This is important right here. The chromatic number of a graph is the least number of colors required to do a coloring of a graph. So let's pretend like I just asked you guys to get a certain number of colors for your homework. How many colors do you think that was? Yeah, I asked you to get 4, right? For your homework, you should need only 4. Should. Okay? So, chromatic numbering algorithm, the steps. Assign color 1 to the vertex with the highest valence. Now, what does valence mean? I didn't say that. Yeah, do me a favor. So it's almost like, other people that actually pay attention, I don't want to hear you say it.
I don't know.
You don't speak for the trees. You're not the one slur. You don't speak for the trees. Fred, do you remember what valence means? Someone else? Anyone recall what valence means? Valence. Yes. Yeah, the number of edges. Number of edges. Do you know what? No, no. Just because you have earned this. You have earned this. Good job. Hold on to that. All right. Highest valence. So that means the highest number of edges. So you go look to find that spot with the highest number of edges. Okay, assign one color to that. Also assign color 1 to any uncolored vertex not connected to this vertex. Okay, so anything not connected to that same vertex, right? So let's take a look and assign color 2 to vertex with the next highest valence. In an example, let's look at this. What is the edges here? Okay, what's the valence here? At any one of these points, actually they're all the same, so what is the valence on this? What was valence? Number of edges. How many number of edges are at this point right here? There's 2 there. How many valence? 2. How many? And 2. Assign one color to the vertex with the highest valence. They're all the same. So, all right, let's go with red. I'm going to do a red. And for some reason, Preston has his phone out again for some reason. That's weird. All right? Okay. Assign color 1. So in this case, color 1 is red to the vertex with the highest valence. Also assign color 1 to any uncolored vertex not connected to this vertex. So if I'm looking at this, connected to this one would be B, right? And D. B and D are both connected to A, aren't they? Say yes.
Yes.
So where else am I going to put the red? Over here, right? Color 2. Okay, so this right here. Assign color 2 to the vertex with the next highest valence that's not already colored. So, look right here. Are they connected? Is the same color connected? No. So, when we look at this, it's going to have a chromatic number of 2. It's a chromatic number, so that means I need at least 2 colors to keep them apart, right? Yes, that makes sense or no?
Yeah.
No? Preston said no. Maybe? Chromatic number is, because how many colors do I need? 2, right? All right, so now let's look at the next one. The highest number of vertices. Highest number of vertices. Let's go through and count them. So this one, the valence on this one is going to be 3. The valence here is 3, right? The valence here is, valence here is, valence here, valence here, valence here, and valence here. Does that make sense so far? We're numbering the valence, and now from there we're going to keep going and start doing some coloring now. So my first color is going to be red. Color 1, start somewhere. There you go. Now, let's look. Which ones are connected to that color? So, by connected color, I'm going to do this just to show you which ones are connected. So that means these ones are all connected. So none of these ones could be a red, right? none of those ones right there could be a red. But I could have red somewhere else though, right? Okay, so now we're on step 2 now since we did that. And it says step 2, assign color 1 to any uncolored vertex not connected to this vertex. So, could I put it right here? Very good. Okay, so I can put it right there, can't I? So, that means that when I do this, this one cannot be red, this one cannot be red, and this one cannot be red. Yes? Okay, so is there another one I could use? Could I use this one over here?
Yeah.
Okay, I could use this one right here. So if I do this one right here, it's not connected to the other ones, right? So it's not connected to the other one, so that means that, again, cannot be red, cannot be red, cannot be red. Can I do it again?
Yeah. Bottom right.
Bottom right. I could do that again, bottom right. So watch this. So now from here, now that I do that, so that means that that one cannot be red, that one cannot be red, that one cannot be red. Does that make sense or no? Am I? So now I've gone through. Is there any other that cannot be red? Or I'm sorry, not that cannot be red, that could be red. Okay, so now let's do a blue. So next one's going to be blue. So I go in the next one. So the ones that cannot be red can now be blue. That one's blue. 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 And blue.
Wait, so the number would be 2?
The number, chromatic number on this one will be 2. Now, I don't have any 2 red colors next to each other, do I? No 2 red are adjacent and next to and touching each other. That's what we're trying to do by minimizing. That in this sense here, the red color is a Fred. The red color is a Smokey. The red color is a Preston. I can't let 2 of those be next to each other, so all of those have to be separate, right? So they can be anywhere in the classroom, but I have to have them separated by someone else, because they cannot be next to each other. And if you look closely, it's kind of what I did here. All right? Just look, going this way. There's at least one person in between Fred and Smokey. At least one person between Smokey and Preston. And if we're on a diagonal between Preston and Fred, it would be the same thing too. Because I can't let you guys sit together, because you guys act fools, right? So that's what it means. That's what it means right here where it says, okay, conflict resolution. Keep those 3 students separated. That's the conflict resolution there. Does that make sense or no?
That makes sense.
Okay, good. Yes? All right. Now, let's go ahead, go up to this next one. Okay, so, all right, so we did right here, assign 2 to any not connected. If uncolored vertices remain, assign color 3 to the uncolored vertex with the next highest balance, and any other uncolored, unconnected vertices proceed till they're all colored. All right, so now let's look at this one right here. What's the chromatic number on this? So let's go through and start by listing the valences. What's the valence on this one? So I'm going to go here, 3, 3, 3, 3, 3, 3, 3, 3, 3, and 3. Now, using the steps that we just did, this one's a different one here, right? I would like for you people right now on your paper, try number 3. Or example 3. I want you to try it. Did you get these already? Oh, why don't you say something? Okay, they're right here though. If you do come in like next time. I'll let you choose whatever crayons you want.
You can use one of the two sides.
No.
You're trying to minimize. The word minimize means the least amount.
That's possible.
Yes, that's possible.
So what if
So
it's
can
not-
the lights come?
Then you would have 3.
So, but I can't.
If you have to, yes. Okay, so Rolling Stone, favorite song. Rolling Stone, favorite song.
I always listen to it before.
No, it's more like Symphony for the Devil.
Oh yeah. So the lights go like this. Like out.
So you're saying like 2 red lines cross?
So yeah.
So, where, are you talking about like here and here?
So I don't know, like here, they're not the dot is.
Okay, so these are connected. These are connected,
Yeah,
right?
so I'll put it right here.
Ye-
It's not connected.
you could, I guess you can because it's not connected to there, right?
But it's right, it's connected. Fine.
Okay, but no, it's connected by the road. Remember, there's gotta be a point there for that to count. If it crosses over it, that doesn't count. That's not a house there. Are you done?
Yeah.
You haven't even started.
Or just a washer.
Man, you took it all the way.
Now.
I haven't even touched mine.
Conflict resolution with Vertex Coloring. Seating charts. Get to work! Zoo animal.
Stop talking about Preston. Dude, that's bullying.
Jungle, get to work. You still haven't even started. Let's go. After you spent all that time looking for sharp colored pencils.
First of all, I sharpened them.
Oh my goodness.
Just right.
I know. If we go to the zoo to see Fred, okay, you guys got to be careful because, you know, the Fred exhibit throws feces.
What? Freddy Dansky?
Saying that one's going to be a 3. I don't have it there. I checked it. What's up?
Yeah, the
Are you saying there's a blue right there? You say there's a blue dot right there? Would that be right next to connecting another blue dot? Would that be 2 blue dots next to each other? Oh, okay. Okay. Why don't you put it next to it to fix it? Because I can't really tell. And I'm not sure you could tell too. Especially after you like go to bed and then you wake up tomorrow and you're like,
Really, two? No, I did. Use 3 colors, didn't you?
Yeah, you can use three. You can
I know I did. Mister, I don't want the tape no more.
Ugh. All right, so let's try this. So hopefully some people are going to. So I'm going to start here, right in the top. Now, for the sake of doing this, I'm going to go through and do the same thing I did, because the connecting lines, they cannot be connected to the next one, right? So I have red here, so that means that this cannot be red, and cannot be read. Huh? Yeah, those dots, those 3 dots cannot be read. All right, so let's see. Now I'm going to pick another one. So if I pick this one here, again, that cannot be read. That one cannot be read. And that one cannot be read. Yeah? All right, so let's pick another one. Bottom right corner.
Bottom left corner.
Bottom left corner.
Bottom left or bottom right?
Choose the bottom left.
Just one of the bottoms.
Either one? Okay, so right here. That means that this one cannot be read, cannot be read, cannot be read.
Yeah.
Any others?
No.
None of the others, right? Okay, because that means there's a red line going to all of those, right? Okay, good. Now I'm going to go to the second color. Second color is going to be blue. So that means that this one here is going to be blue. So that works out, right?
Yeah.
That means all points going to that one are red, so that means that one's going to be blue. Okay, another one.
Bottom left.
The middle left.
Bottom left.
Bottom middle left.
You're peeking
Yeah,
right
right there.
there.
Either or. So let's go with this one. So that means that cannot be blue and cannot be blue, right? All right.
And bottom right.
You say bottom right?
Yeah.
Okay. Bottom right. So that means this one cannot be blue and this one cannot be blue.
Top right.
Right there?
Yeah.
This one. So that means that this one cannot be blue and that this one cannot be blue, right? Yes?
Yeah.
So I have 3 dots here that cannot be either blue or red. So what does that mean? I need another color, right? I need a third color here. So for the third color, let's go this green thing. There's my third color. So this one right here is a blue and red also. Third color, blue and red, third color. So the chromatic number on this problem would be
40.
chromatic number is going to be 3. The reason why this one changed, even though that the valence is 3 here, just like my previous one, this one changed because I have more lines connecting. So there's more roads going in between. Even though they all have a valence of 3, there's a lot more roads here. And let me fit this back again. And right here it says vertex coloring problems are important when it comes to problems that involve potential conflict. It can help you determine which thing can be avoided or which can be grouped together. Seating charts. Exactly. Student and teacher schedules, airline routes, and zoo animals. So we cannot put chongos next to anything that might get in trouble if they get poo thrown at them, right? If you've been to the zoo, like seriously, the monkeys, they throw poop. It's gross. Yeah, don't do that. Anyway, fish sorting. Fish sorting. There we go. Sorry. It says a hobbyist has 6 different types of fish: alphas, betas, certas, deltas, epsilons, and thetas, which will be labeled A through F because predator-prey relationships, water conditions, size. Some fish can't be kept in the same tanks. What is the smallest number of tanks needed to keep all the fish? So, on this one right here, each vertex, each edge here represents what? What do you think it represents? The valence, right? The edges are going to be the valences, right? But in this context here, what do you think it represents? Each vertex is going to be the different fish, right? And each edge connecting would be it would be the going with the tanks, right? Like how are they associated with each other? So let's go ahead, and I am going to at least draw this, and I'm going to make it bigger again. So we have 5 of them. So we have 5 fish. So we have wait, there's an F in there, so that makes 6. Did I do that? 6 fish, yes, sorry. So, in this one right here, so we're going to put some relations here. So that means there's going to be connections in between them. So for this one, type A cannot go with B or C. So type A cannot connect to B or C. Type B cannot connect to A, C, and E. Right? Type C connects to A, to B, to D, and to E. Yes? D is going to connect to C and F. D goes to C and it goes to F. E goes with B, C, and F. That was weird. Really? Come on. There you go. And F goes with D and E. Yes. Now that I have this mapped out, what's the first thing I should do? What was the first thing we did on those other problems? Number the valence, right? So C has 1, 2, 3, 4, right? B has 3, A has 2, 2, 3, and 2. Yes? Does that make sense or nonsense? Looks like people are just starting to zone out on me. I'm getting worried. Now, we start with which one? Which one are we going to start with? Nope.
Wait, one second. What did you make?
Huh? Why am I going with C? It's the highest. I'm going to start with C. It's the highest valence, right? Okay, so I go there. So I start there. C is the highest. So I start there. So that C cannot connect to B, A, E, and D. Now, can I use C anywhere else? I'm sorry, not C. Can I use red anywhere else? At F. There we go. We could use it at F. So we could use it right there. So that means that cannot be red, also cannot be red. So let's go ahead and change colors now. What's the next highest?
E.
E or B, they both have 3, right? So, let's see. If I go B, I'm going to go blue here. So that means this one here cannot be blue. This one here cannot be blue. I'm still going to use the third color anyway. If I chose E, that one would have had to be a different color anyway. Now, can I use blue anywhere else?
D.
At D, right? I would go right here is blue. Anywhere else? No. Okay, so now I am going to need a third color here. Because if you look over here at A, there's 2 different colors going to A already that it cannot be. So that means that one's going to need a third. And over here at E, which I have 2 different colors going to there, right? And that's going to be the next highest one that I'm going to go to. There's already, I cannot be blue, cannot be red, so it has to be a third color anyway. So I'm going to pick this ugly color. So the 3 goes next, which is here. And there's nothing to cancel out for this, no lanes to cancel out. And then A is going to get that color too. So in this, vertex represents the tanks. Actually, no, vertex is the fish, right? And edges connection is the relationship in my tanks. So, what is the chromatic number on this? 3. And so in this instant, what is the minimum amount of fish tanks I could have? 3. The chromatic number here represents the number of fish tanks. So I need, I think it says down here, 3 fish tanks. Now, does that make sense or no? Maybe? Just one of those things, right? Okay. All right, let's see. Now, looking at that, going to full size again. All right, so if you look right there, this is actually the notes for 5.3 through 5.9. So the next couple of days, we're going to do some homework practice to go along with this. But take a look at your assignment right now. Please, please, please take a look at the assignment, the homework right now. All right, hopefully pull this one up. And it should be coloring map. And if you look right here, I eliminated a whole lot of your problems. So you only have this page right here, because there was a whole bunch more pages to go along with this, and I figured, you know what, just one would be easiest. Consider figure 5 right here, in which country A is represented in 2 pieces, right here and here. Yeah. I said separated? Oh, I'm sorry. Consider 5 in which country A is separated in 2 pieces. So, if we look right here, if I was to do the coloring on this, I would start with A, because if you notice, A is touching D, C, and B. Right? So I would give this one a red.
Wait, it said it's cut into 2 pieces.
I know. This one's this, red. But A is also over here, right?
Oh, there's the A right there.
Yeah, so that means it's in 2. So that means that A is touching, it's touching B, C, D, and E, right? So the different colors that are needed, so I can't use, can I use red anymore? Say no.
No.
Good. So I'm going to pick another color right here. And let's see what I could use. Let's start off with, next one's going to be, this is touching, so C, if you look at C, C is touching D, B, and E, isn't it? Okay. B is touching, and A. B is touching A, C, D, and E. So it's touching all those. So that's going to be, the valence number would be 1, 2, 3, and 4. So it looks like all these other ones have 4 here. So I'm going to do B in blue. So blue is touching C, A, D, and E, right? So to color this correctly, can I put blue anywhere else? No, cannot put blue anywhere else. So I'm going to go with one of these oranges right here. So the next highest valence is probably going to be C here, right? Maybe? Okay. I'm just going alphabetical order because, you know, I think D has the same number. D is touching A, B, C, and E. Yeah. Anyway, same. Yes? All right. Can I put this orange anywhere else? No? Can't put orange anywhere else? Good. I'm going to go purple. That's going to go D. So, I'm on purple. There's D. Now, can I put purple anywhere else? Nope. Okay. And so that means I need another one for E.
These are 4 colors. That's 5.
Consider figure 5 in which the country A is separated in 2 pieces. Are 5 colors necessary? Are 5 colors necessary? How many colors did we use? I used 5, didn't I? So, I apologize. I said 4 when it's supposed to be 5 because I was looking at this one right here. If you guys look, please, please, please. right here it says 4 colors are enough to color this map. So you only need 4 for this. I forgot about this one that you do need 5. All right, so I'll let you work on this, do some coloring. Now, I highly recommend, where do you think I should start at?
Washington.
Nope.
Cali. Texas.
New Mexico. Kansas.
Mississippi. Wait, Texas. Texas. Arizona.
All right, okay, for the video, I'm gonna stop the video here, and then I'm gonna let you guys try to figure this out. So don't forget, like, share, subscribe, hit that notification, and buy stuff from my merch store.
Texas, Texas.